probably under 30 minutes. So we have a third order solution. So we need three independent solutions over here. One, two, three. That's how you decide this. And after that, we have to do the solve the homogeneous solution, which is basically making this side equal to zero and solving this portion so we can get the characteristic differential equation that will be part of the solution. But because of that GT or the forcing, we need to get the ET later on, which is where this portion, the particular solution, is needed, and you'll add up the particular solution with the particular solution to get the final answer. Now, to get this thing, the third order differential equation, so first thing you have to do is make some human assumptions. Because it's a third order equation, we can make two different assumptions or constraints that humans made. And don't worry about it, it's not arbitrary. It actually makes it easier for us to deal with it because these constraints are built into the system to make it possible to get these three solutions over here. Now, as you can see over here, there's a long proof over here. If you want to read it, you can, but this proof shows you how I figured out the last one over here, where we figure out this last one. But do you generally need it? No, because we can see a pattern over here where we see a Wolski on the top, Wolski on the above, and then you can see that goes above over here, and you can see that if it's a fourth one, you just have to increase the amount of Wolski and the variables and Wolski and variables down over here, and that's it. And you'll see that pattern go, go, go. And then you solve all this, and then the last few parts is basically any other, you can think about any other solution. So anyways, but we need to also talk about the second order solution because there's a little difference between the third and forever, like fourth, fifth, sixth, seven, eight, and also initial conditions in the end. With the second order solution, where if you do the same thing, you get a slightly different kind of variables over here. You see, there's no longer a Wolfskian because there's no such thing as a one variable Wolfskian. So there's a different final solution you get to solve for. And you need to solve it, you get an answer, and that's it. Anyway, that was 3 minutes, right? All right, I'm done. All right, stop recording. I'm currently working on Laplace transformation next. Gonna do this part real quick and then quickly go into Fourier. So actually Fourier should be on top first, but I know Laplace better than Fourier's. That's why I decided actually I'll keep the order. I'll do Fourier's first. But anyways, I think.